Hello. I would like to read my paper to you, but as I have a problem with dyslexia, I could face some mistakes in reading, so I hope you will understand. My name is Goran Ćosić and I'm a philosophy teacher. It is my opinion that Einstein misunderstood the concept of time and time dilation. Today I would like to explain why and how he made that mistake. Einstein did not discern time from causality. For him, they were one and the same thing. Consequently, according to the special theory of relativity, speed is taken as a factor that slows down time, while according to the general theory of relativity, gravity is taken as a factor influencing time. In other words, the stronger the gravity, the slower the time, and vice versa. The weaker the gravity, the faster the time. However, as I will explain, that is one of the delusions of modern physics. With regards to time, causalities embrace much wider range of factors and patterns they create. For them to be included in such narrow frames and identified by the theory of relativity. Each causality contains its own necessities. Different factors influence the accelerating or slowing down, the aging or deteriorating. In any case, it always boils down to processes moving from causes towards effects. The assumption that all those processes are equally guided by the two already mentioned factors, namely gravity or movement at a great speed, is actually a logical mistake. This brings to mind Bacon's Idols of the Tree, where the nature of our mind is identified with the nature of causality. Or in the other words, with natural processes. For example, if we were to move at high speed, our clock would have to tick its time more slowly, without us being aware of the facts that we are moving or that our clock is ticking more slowly. Consequently, the very movement should slow down the aging with respect to the people at rest. If we consider the moving capsule, time in the capsule should be different in relation to time, people and clock at rest. If there is truly a slowing of time, all the clocks within a system in motion should measure time equally. Therefore, if we had an observer and a light clock placed in a moving capsule, the observer in the moving capsule would observe the clock ticking at a certain fixed rate because the observer would see that light moving from one mirror to another, converting always the same length. However, an observer at rest, with respect to the observer in motion, would observe the moving clock differently and would see the light converting a longer distance going from one mirror to another. Therefore, the observer at rest could assume that time passes more slowly for the observer in motion. However, let's consider what would happen if we were to place two identical light clocks into a moving capsule and position them differently. The clock marked as number 2 would be placed at 90 degrees with respect to the clock marked as number 1. or in the other words, the clock number 2 would be positioned in the direction of movement. Let's say that the speed of the capsule is half the speed of light. That is approximately 150,000 kilometers per second. If Einstein is right, the two clocks would appear to measure time in one manner for the observer in motion and in a different manner for the observer at rest. Let's take that our clocks measure 5 meters in length. This means that there will be a length contraction regarding the clock number 2 for the observer at rest. The length of the mentioned clock would measure 4.33 meters and the light would need to travel 4.32 times 2 or 8.66 meters due to the movement of the clock at the half the speed of light. So, in the light clock number 1, the light would travel the distance of 10 meters from and back to mirror A, as seen by the observer in motion. However, as I have already mentioned, the situation is different for the light clock number 2, where the light would cover 8.66 meters traveling from mirror A to mirror B, being now in the position B1. After hitting mirror B, the light would travel back to mirror A, which is not traveling from mirror, which is now moving towards the light and would cover additional length of 2.88 meter or in the other words, the light would cover 2/3 of the clock's 4.33 meters. Therefore, passing and measuring the clock's contraction of light. Therefore, the light would cover 2/3 of the clock's length while moving from mirror B to mirror A, while the mirror A itself would cover 1/3 of the clock's length while moving in a direction of light. For the observer in motion, this means that the length of the clock number 2 measures 11.55 meters from and back to mirror A. Well, this value is 10 meters for the clock number 1. Now we have a situation where the observer in motion has two identical clocks measuring different time. For the observer in motion, the clock number 2 looks the same, and one cannot see that mirror B moves ahead of the light beam as is obvious for the observer at rest. However, even though that observer in motion sees the distance between two mirrors of the clock number 2 as symmetrical, the distance is not symmetrical anymore for the beam of light, as is take longer for the click from A to B and shorter from B to A. The faster the speed of movement, the longer the click from A to B and shorter from B to A, and vice versa. We are talking here about the necessities of these causalities. Thanks to the two clocks, the observer in motion could know that he or she is moving without looking out of the window. One could deduce that already from the asymmetrical duration of the clock's duration of the clicks from A to B and B to A in the clock number 2. The clock number 2 would measure equal time both for the observer at rest and for the observer in motion. So, if we had only one clock, the clock number 2 that is placed in a direction of movement, both the observer at rest and one in motion would measure time equally. On the other hand, we could take two equal light clocks and place them horizontally, one next to the other. For the sake of illustration, the point we will make clocks and photons is in opposite direction. One clock would send photons in the direction of movement, the other in an opposite direction. Also, each time the light would strike a photon counter, a new beam of light would be sent. Or, in the other hand, a new beam of light could also be sent at the same interval. So, how would the two clocks measure time, one in relation to the other? And also taking into account the both observers. The measuring of time for both clocks would be identical for the observer at rest and for the observer in motion. However, the measuring of time between the two clocks would not be the same. So, what kind of the time dilation are we talking about? So much about the special theory of relativity. Let's deal with the general theory of relativity postulate that make an experiment placing an atomic clock in an area with increased gravity and observe it actually ticks more slowly. This still certainly is not a proof that would permit us to talk about the time dilation. We can only talk about the possibility that certain factors, gravity in this case, could influence the acceleration or deceleration of a certain process. An atomic clock in this case. Now let's place other clocks next to the atomic clock, such as sand clock, pendulum, or mechanical clock with a downward moving weight. Due to the operating principles of these clocks, the increased gravity field would make the clocks run faster, completely opposite to the atomic clock. What would happen to those clocks in the field of decreased gravity or zero gravity? Here we came to the point where we can form a clear question. What does actually a clock do? Does it measure time, or it is a clock merely a group of causalities necessarily determined by the laws that define the clock's function? What would happen if we increase gravity to 10 Gs in a certain city? Would time run more slowly in that city with respect to a city with 1 G gravity? Of course not. All citizens would die, houses would collapse, grasses would be flattened, trees would fall down. After a period of accelerated movement and devastation, everything would come to a stop and could not be easily moved anymore. Every single process, every single causality has its own laws, by which it is necessarily defined. Therefore, each clock measures time according to the causalities that determine and dominate the process of measurement. This also holds true for all the other processes. The aging of a human being. The aging of the human being depends on numerous factors, starting from diseases, state of mind, nutrition, gene mutation, and so on. For the theory of relativity to hold true, the overall time with its complex causality would have to fall under the universal influence of the two mentioned factors, namely fast movement and gravity. However, this is not the case. Things are more complex than that. If you wanted to know more, you can refer to my book where I talk about the solution to the problem of causality. Causalitas constans. In the nature of causality, things are completely different. Nature is not molded the way it is described by the theory of relativity. Nature is much more free, spontaneous, and complex than that. And many more scientists will yet try to form theories with the aim of catching the Gardner Hall physics at work. Using the same thinking, scientists could have formed a thesis stating that time had slowed down in cooler conditions by observing nature at work during winter time. In winter time, as we know, nature falls, sleeps, food declares more slowly, and many processes slow down or freeze depending on the temperatures dropping. Now let's create a sound clock and then place two identical sound clocks in the two different rooms. One at a temperature of 25 degrees Celsius, the other at the temperature of 25 degrees Celsius below zero. Let's have all the other possible factors identical in both rooms. We can observe that the clock placed in a cooler room works more slowly because one of the factors that influence the speed of sound is temperature. Would that mean that time really slowed down in that room? Absolutely not. That is only one of the factors that influence the process, and it's slowing down. The same goes for the atomic clock placed in a satellite that circle around the Earth, and their effect of their different function. I dare not say measuring time, because the influence of decreased gravity or movement are just some of the factors that influence the function of those clocks. There is no magic hand that would slow down time under the influence of gravity or movement. Such a thinking is only one in a series of flattened paradigms. There are many different factors, and each of the factors, according to its own laws of causality, influence different processes. Time does not exist as an entity from the outside. I hold that the greatest truth about time and the first altitude towards time is that time does not exist as such. Physics, or in other words, nature, has created processes, and we have created the experience of time as our relation to the duration of the natural processes. It is an evolutionary experience that will evolve along with the development of the human race. It is highly unlikely that anyone would ever find a factor that could slow down time, when time in that mentioned context does not exist at all. What actually exists are causalities and their different laws. The slowing down of time, according to theory of relativity would premise factors that would have the same influence on all processes, and that would, thanks to its universal effects, change time in the processes they affect, compared to the processes they do not affect. What is that which could be said to have equal effects on our telomeres, DNA endings, that regulate the regeneration of our cells, clock click or food deterioration? This is where Einstein misunderstood the concept, misunderstood the relation between causality and time, and where erroneously the concept of space-time was created. It would be more just to say that space, causality, and time, as Einstein viewed them, and their relation are not compatible with the nature of causality. Einstein believed that gravity and movement were two factors that exerted universal influence on time. The point is that in order to understand time, we should have first resolved the problem of causality and then make a clear distinction between causality and time.